gravitational pull on the near side than it does the far side of the Earth, and that's sufficient to circulate the liquid iron and establish a magnetic field, and you get an even more powerful tidal effect on the moon exerted by the Earth. And so, looking at what it takes to really have a habitable planet, but making the point, hey, that's one criteria for habitability. You're not even going to get microbial life, let alone advanced life, unless you're really working with a rocky planet the size of the Earth, the appropriate distance from its host star, where that rocky planet is being orbited by a single gigantic moon like our moon. You basically need an Earth-Moon system identical in its characteristics to our planet Earth and our moon, with the identical formation history. The moon formed as a direct result of two planets in our solar system colliding with one another, where the smaller planet got absorbed into the Earth, and a debris cloud around the now bigger Earth led to the formation of the moon. I describe this in quite a bit of detail in the next book I'm bringing out, Design to the Core. It may be out next month. There's a problem with trying to get paper to print it. It's been at the printer now for 2.5 months, but they told us latest it'll be out in July. And a lot about what I'm going to be sharing today comes from this book, Design to the Core. And you'll also see some in this book, The Crater and the Cosmos, 4th edition. And you can get a free chapter of that book. Anyone can get a free chapter of that book by going to reasons.org/Ross. But I want to begin this talk with something that got discovered just days ago. I wasn't anticipating this last week, but it got announced. And that is, they have now successfully imaged the event horizon of the supermassive black hole that's in the center of our galaxy. That was actually part of my talk, but I wasn't aware that they're actually going to have the image being published. So I'm going to actually show you the image. And it was a direct result of a network of high precision millimeter wave telescopes all over the world. And so this map just shows you where they were able to find these radio telescopes that have the capability of making observations at millimeter wave lengths. In fact, it was done at 1.3 millimeter wavelengths. And for that to be possible, you have to have your radio telescope in a very dry location at high altitude. And so the two best locations are in Chile at 17,500 feet. The driest desert in the world is in Chile. And at 17,500 feet, there's so little water in the atmosphere, it doesn't really block out or prevent the incoming millimeter wave radiation. And then the next best place is at the South Pole, where it's so cold it basically freezes out all the water. But they found other locations too, some here in California, some in Hawaii, basically high altitude dry locations. And they linked together all these telescopes, and basically they, at radio wavelengths, you have both the amplitude information from the incoming radiation, and you've got the phase information. At optical wavelengths, all you get is the amplitude. You don't get the phase. But because of radio wavelengths, you get both the phase and the wavelengths. That makes it possible to link together radio telescopes separated by thousands of miles, and you're basically producing a telescope that's got the equivalent diameter, in this case, of over 6,000 miles. And so you think of the Hubble Space Telescope, which has got, about 2.5 meter diameter lens. You've got that huge telescope that's on top of Mauna Kea in Hawaii. It's 10 meters. This thing is 6,000 miles. So it explains why it has such exceptional resolution. And the James Webb Space Telescope, that's now operational about 1 million miles from the Earth, it has an extraordinary resolving power of 0.1 arc second. You say, well, what's an arc second? Okay, take a circle that's 360 degrees, and each degree is 60 minutes, and each minute is 60 arc seconds. So we're talking 1/10 of an arc second. And to give you an idea about what that means, I've got here a side-by-side comparison of what was the world's best infrared telescope until the James Webb got launched. That's on the left. The Spitzer telescope has ranked, by the way, NASA has sent up 4 infrared telescopes into space, and until the James Webb went up, the Spitzer was the best. But this image basically is a side-by-side comparison of the same part of the sky where you've got Spitzer on the left and you've got the Webb, James Webb Space Telescope on the right. And you can see how much superior the light gathering power and the resolution is with the Spitzer with the James Webb Space Telescope. But it literally ranks 4,000 times inferior to the resolution that you can get with this array of radio telescopes. And the array is referred to as the Event Horizon Telescope. It's the only telescope that astronomers possess that has the resolution to actually determine the diameter of a black hole. And you're basically measuring the event horizon of the black hole. So what is that? Well, as you approach a black hole, there's a certain distance relative to the center of the black hole where the gravity is so strong that nothing can escape the pull of the gravity. And that would include even light itself. And so when you do image a black hole, you reach a point where you see this little black circle, and that means that you have actually imaged the event horizon. And I'm going to show you. This literally got published just days ago. I think it came up on Wednesday. I think it was Thursday that they came. Yeah, it was Thursday that they released it. And I knew this was coming because back in 2019, they published this image of the event horizon of the supermassive black hole in the galaxy M87. And the black hole in M87 comes in at 6.5 billion times the mass of our star, the sun. So it's the closest what we call supermassive black hole, which means a black hole that comes in at more than 1 billion times the mass of our star, the sun. And they knew right away that this is going to be the easiest one to image. So it's the first one they focused on, and this got released in 2019. And so you can see that little black central part. That is the black hole, and the edge of that black, the farthest edge, that's the event horizon. Anything that gets closer to that can't escape. And you say, well, what's all that orange light that you see around it? Well, what happens when matter begins to approach a black hole is that it begins to move very rapidly around the black hole, then it gets sucked into the black hole. But just beyond the event horizon, matter gets converted into energy with anywhere from 10 to 42% efficiency, which is the greatest conversion of E equals mc squared. I found no matter where I speak in the world, everybody knows E equals mc squared. They may not know F equals ma, but they know E equals mc squared. E is energy, and m is mass, and c is the velocity of light. It's Einstein's equation of special relativity, which makes the point you can convert matter into pure energy, and you can take energy and use that to produce matter. And in this case, matter is being converted into energy with 10 to 42% efficiency, which explains why you get this bright circle of light just outside the event horizon. And to give you a point of comparison, our star, the sun, all stars that are fusing hydrogen to helium, the fusion of hydrogen to helium, which is basically the hydrogen bomb process, you're converting matter into energy with 0.07% efficiency. So here you can see it's orders of magnitude greater than the energy production that you get in a typical star. And if you want to know what a quasar is, A quasar is a supermassive black hole that is sucking copious amounts of matter into it, and that matter gets converted into energy with 10 to 42% efficiency, which is why we can see these quasars billions of light years away. They're bright in the sky. I mean, the telescope I own, which is an 11-inch optical telescope, I can use that telescope to see distant quasars just because of how efficiently matter is being converted into energy. Astronomers knew that it'd be much more challenging to image the event horizon of the black hole of our Milky Way galaxy for two reasons. Number one, the mass of our supermassive black hole is really small. It's only 4 million times the mass of our star, the sun. That sounds a lot, but when you consider that our Milky Way galaxy has a mass of about 1.3 trillion times the mass of our star, the sun, 4 million is not much. Matter of fact, for galaxies of the size of our Milky Way galaxy, it's got by far the smallest supermassive black hole. I mean, Andromeda, for example, has a supermassive black hole 140 million times the mass of our star, the sun. And it's typical. Our galaxy is atypical, and it's got such an extremely tiny supermassive black hole. Now, what makes up for that, it's close by. I mean, in this particular case, you're looking 53 million light years away. And, but because it's such a gigantic black hole, they were able to come up with this image. In the case of our Milky Way galaxy, it's much closer. We're only looking at about 26,000 light years, so it's nearby. But because it's so tiny, and the other challenge is, unlike the super in M87 that's sucking in a lot of matter that's being converted into energy, the supermassive black hole in our Milky Way galaxy presently is in a quiet phase. The biggest objects that are being drawn into it are the sizes of relatively mediocre comets and asteroids. So it's not consuming stars, it's not consuming planets, it's not consuming bodies as big as our moon, it's consuming relatively small asteroids and comets. Matter of fact, we astronomers know there's a cloud of asteroids and comets surrounding the supermassive black hole at the center of our galaxy. But the problem is the energy that you get is orders of magnitude weaker than what you get here. So it explains why it took them an extra 3 years to accumulate enough data that they could actually image the supermassive black hole. So that little black region in the middle there, a little bit blurry, but that is the event horizon of the supermassive black hole in our galaxy. And the team that announced the results a couple of days ago basically said we're going to continue the observations until we can get a sharp distinction, a sharp boundary for that supermassive black hole. But it confirms something that I put in my book, Design to the Core. It said everything we know about the supermassive black hole, the fact that we're seeing such feeble radiation coming out of it, tells us it can't be sucking very much matter into it. It's really weak, and but that this set of observations basically confirms that. They were able to detect the radiation outside the black hole, but it was extremely difficult to detect it because of how extremely weak it was. But they pulled it off. It took 5 years of observations to get it sensitive enough where they could see it, but they now actually do see it. But when they published their report on Thursday, they basically said, we are fortunate in that we humans are living on planet Earth in a window of time when our supermassive black hole is not very active. It's really not sucking anything significant into it, and therefore it's safe for us to live here. And what I'm going to be sharing with you next week, we now know there was a big incident about 5 to 7 million years ago. In fact, we can actually see the X-ray bubbles from that time when our supermassive black hole was not as quiet as it is right now. But yeah, we're fortunate. We're living here on planet Earth at just the right time in the history of the supermassive black hole and the center of our galaxy. So here's M87 again. And hey, if you want to read more about it, I actually got a paper published in a secular peer-reviewed journal. It's called Black Holes as Evidence for God's Care. And people this week have been asking me, hey, in light of this published release, are you going to have to revise anything in the paper that you wrote? The answer is no. Basically, everything I wrote in the paper has been affirmed by this discovery. But yeah, if you got friends, feel free to send them to that paper, Black Holes as Evidence of God's Care. That's all you got to put into the search engine. It'll pop right up. But let me jump into some other new material here. Last week, I introduced to you the most constraining habitability requirement, planetary habitability requirement. There's galactic habitable zones. There is extragalactic habitable zones, galaxy cluster habitable zones. There's even super galaxy cluster habitable zones. But what I want to talk about here are planetary habitable zones. And last week we talked about the need for a coupled magnetosphere. And if you want a basic definition of a planetary habitable zone, it's basically referring to that range of distances from the host star where a planet could conceivably have life existing on its surface. And they're simply talking about simple life, not advanced life. For advanced life, the planetary habitable zones are orders of magnitude thinner than they are for microbial life. And so there's a planet's orbit relative to its host star that plays into this, but the other crucial factors is the type of star and the type of planet. And so like in Design to the Core, I've got a whole chapter basically saying, okay, it doesn't even matter whether or not the planet's in the habitable zone. You have to have a very special kind of star. And what kinds of stars do you need? And I'll give you a little tip. The chapter basically makes the point. We've scoured the entire Milky Way galaxy looking for a star that would be the right type on which you could have a planet orbiting it with advanced life, and we haven't found any. The sun remains alone. Now, there are other stars that are candidates to have a planet orbiting it on which microbes could exist, especially microbes that could exist for just a short period of time. Lots of stars fall into that category, but we've yet to find a twin of our star, the sun, that has the characteristics that would allow advanced life to exist on a planet orbiting it. So the type of star is crucial. The type of planet is crucial. If you want to have advanced life, you need a planet that's got coexisting oceans and continents on its surface. The atmosphere has to be a certain thickness, of a certain composition. It's got to be a planet that has a stable, strong magnetosphere with plate tectonic activity. And again, I've got a chapter in Design to the Core saying we have found 5,000 planets outside of our solar system. Many of them are referred to as Earth-like planets. But all the Earth-like planets we have found have water that's 500 times or more abundant than it is on Earth. You say, well, I thought water is good for life. Too much water is deadly for life. Because what happens when you got, say, 500 times as much water, you're going to have deep oceans. And with deep oceans, you're going to have really dense water at the bottom of the ocean. And we're all told that ice floats. It does if you have normal, dense water. But if you've got oceans that are, like 1,000 kilometers deep, the pressure at the bottom of the ocean will be so extreme, you get ice forming at the bottom of the ocean. It only forms under very high pressure. Where you've got lots of water, you're going to have ice forming under those pressures, which means that planets that are Earth-like with that much water, you're going to have a layer of ice that's going to prevent the liquid water from having any contact with the rocky interior. And if the liquid water cannot make contact with the rocky interior, there's no possibility for any of the chemical reactions that even the simplest life needs. And so far, all the planets we have found that Earth-like have this enormous amount of water. They also have about 1,000 times or more carbon than we have. And that would be manifested with a really thick atmosphere, and the carbon would show up as carbon dioxide and methane. Those are greenhouse gases. So even at a fairly dim star, it will be absorbing so much heat from that star, it'll be blistering hot on the surface. Similar to what we see in Venus. Venus has an atmosphere 90 times thicker than the Earth, and what's the temperature on the surface of Venus? In Fahrenheit degrees, it's about 810 degrees. Much hotter than what you need to melt lead, for example. So don't think about taking vacations to Venus, not a good idea. Now, we mentioned last week, how did Earth survive not having a very thick ocean and a very thick atmosphere? It was the merger of the proto-Earth with the planet Theia. That merger event generated so much energy that it basically eliminated almost the entirety of Earth's water and the entirety of Earth's atmosphere. And so we got a thin layer of atmosphere and a very thin layer of water. And thanks to the coupled magnetosphere that the moon contributed to, that water and atmosphere did not get sputtered away by the sun. So in terms of planets outside the solar system that are Earth-like, they come into two categories. Category 1, no water at all, no atmosphere. Category 2, they got an atmosphere hundreds of times thicker than the Earth, and with a water layer that's hundreds, if not 1,000 times thicker than the Earth. And so when you read the scientific literature about habitable zones, they talk about the liquid water habitable zone. And so you'll often see in popular articles, NASA thinks there might be 40 billion habitable planets in our galaxy alone. All they're looking at is one of these habitable zones, the liquid water habitable zone. And they define that as a planet that's an appropriate distance from the star that it could have liquid water on its surface. But as I've already mentioned, that's not really a liquid water habitable zone. The liquid water must be there at the just right temperature and the just right quantity. And actually, to have any possibility for life, you need a planet that has on its surface water in vapor form, water in liquid form, and water in frozen form. And so, as NASA defines it, any kind of water in any amount existing for even a short period of time, they call a habitable planet. The truth is, a liquid water habitable zone is much more constraining than they define it. But in addition to the liquid water habitable zone, you got the ultraviolet habitable zone. If you don't have enough ultraviolet radiation coming in, several life-crucial biochemical reactions won't operate, and life will be impossible. But we all know too much ultraviolet radiation is not a good thing. Not only do you get sunburn, if you get a lot more ultraviolet radiation, it kills all life. And so you need to be a certain distance from a just right star to get the just right intensity and wavelengths of ultraviolet radiation. And what astronomers have discovered is it is really rare to have a planet that is simultaneously in the liquid water habitable zone and the ultraviolet habitable zone. In fact, of all the stars we exist in the universe, even with the most generous definitions for the liquid water habitable zone, like the one NASA uses, and the most generous definition for the ultraviolet habitable zone, less than 3% of all the stars in our galaxy would have any possibility of a planet being in those two zones. But as you can see in this list, there are other requirements. You have to be in the photosynthetic zone. That's assuming you want photosynthetic life. Now, you can have microbes that are not photosynthetic, and they can tolerate a lot more variability. But these are life forms with a metabolic reaction that's 10,000 to 10 million times less than photosynthetic life. or any life that's based on oxygen. And so that means, yes, you could have life, but the metabolic rate is going to be a factor of 10,000 to 10 million times less, which means it's a life form that's not going to be able to adapt to any changes in its environment. And stars change, planets change over their history, and so that would be life that would have a very short lifespan. You really need to have life lasting for any period of time. I'll go into the technical details of these. You got the tropospheric ozone, because you need an ozone layer. The rotation rate of the planet needs to be fine-tuned. The rotation axis tilt. There's the what we call the planetary tidal zone. You need the tides to be not too strong but not too weak. Astrosphere refers to the atmosphere around the star. That too needs to be fine-tuned, and all planets have atmospheric electric fields. Venus has way too strong of an atmospheric electric field. In fact, any planet that will be closer to its host star than Earth is to the sun will have an atmospheric electric field that will quickly totally desiccate the planet. So there's a reason why Venus and Mercury are bone dry. Venus doesn't really have much of an atmosphere. Venus does, but because of how close it is to the sun, it's got an atmospheric electric field strong enough to quickly desiccate the planet. I won't go into the details of the Milankovitch cycle. If you're interested, there's a chapter on that in my already published book, Weathering Climate Change. But these are the three most recently discovered ones. That there is a carbon dioxide habitable zone, a carbon monoxide habitable zone, and what we discussed last week, the coupled planet-moon magnetosphere. And here's the bottom line. Unless you got God supernaturally intervening to make sure you got a planet that resides in all 13 habitable zones. And these are the known habitable zones. Following the scientific literature, we're discovering new planetary habitable zones at a rate of about 2 per year. So last year they discovered 3 new ones, and I'm thinking maybe this next year we'll discover at least 1 new one. But just based on the ones we know, let alone not the ones we don't know, is that for a planet to be truly habitable, it must simultaneously reside in all 13 of these known planetary habitable zones. And in addition to that, it has to reside in the known galactic habitable zones, and the known galaxy cluster habitable zones, and the known supergalaxy cluster habitable zones to be truly habitable. And this is why I say, hey, this isn't going to happen by random chance. Unless God supernaturally intervenes to design the star and the planet and put it in the right location, you're not even going to get the most primitive microbes possibly existing beyond planet Earth. So in answering the question, are we alone in the universe? Well, even the microbes on planet Earth are alone unless we have a God that supernaturally intervenes. And that's when we said, when we looked at the Bible text, the Bible does not constrain how much creation activity God has done. It's possible that he created another planet somewhere else in the universe and put life on that planet. But the question that's usually asked is, without God's intervention, is it conceivable that we could have life beyond planet Earth? And basically I'm saying not even microbes are possible, let alone plants or animals, let alone the equivalent of human beings. Important caveat, I've been on record since the 1990s. We will find the remains of microbial life on virtually every solar system body. The reason why is that Earth has been so prolific with microbes for so long that every time big meteors hit the Earth, those meteors eject Earth's soil into interplanetary space. And that soil gets deposited on the moon, on Mars, on Venus, all the solar system bodies. It does not go beyond our planetary system. And so yes, some stuff does get exported, but if you're talking interstellar space, once you get past about a light year away from the Earth, the amount of radiation exposure and the decay time is such that you're not going to have any recoverable remains of microbial life. But within our planetary system, yes, it's possible. And I've been on record since the 1990s, early 1990s, the best place to look for those microbes that have been transported from the Earth is on the surface of the moon. Because we know the moon has a minimum of 20,000 kilograms of Earth soil for every 100 square kilometers. Mars is the next best place to look, but it's got only 200 kilograms for every 100 square kilometers. So it's going to be much easier to find on the moon than on Earth. And we discussed the origin of life last week. What's fascinating about the moon is that it's a reservoir of the history of Earth's life. Earth's geology has destroyed much of the evidence of Earth's early life. So for example, we know there's no hope of finding the fossils of Earth's life here on planet Earth. The geological processes destroyed them. All we got is isotope evidence. We don't have the fossils. They've been destroyed by Earth's geology. But the moon has had almost no geological activity in the past 4 billion years. So we can go to the moon and we will find the pristine fossils of Earth's first life. In fact, years ago I got to speak on this to the team of scientists at NASA when I was at the Houston research facility there, and basically said, we need to go back to the moon, because the Apollo mission was designed to recover pristine lunar rocks. And so I was saying, we need to go back to the moon, and we don't need to send people. Machines will do the job for a lot less money, and with a different mission to recover the Earth's soil that's been deposited on the moon. And to give you an idea of the microbial density, 1 ton of Earth's soil has 100 quadrillion microbes in it. And so that stuff got deposited on the moon. We can go to the moon. We'll find the fossils of Earth's first life. And what I got to share with those NASA scientists is that Christians and theists in general have a very different model about what the first microbes on Earth will look like. Basically, that it will be an ecosystem, not just one species, but multiple species of all different sizes with a broad range of gene products. Whereas the atheistic model basically states we're going to find one species and it's going to be a microbe only 1/10 of a micron across with very few gene products that are making it. I said, go to the moon and we can determine who got it right, the atheists or the theists. And I said, everybody ought to be excited about funding this, because the last time I checked, 100% of US taxpayers are either atheists or theists. Therefore, let's go for it. And I got a good response there. But actually, I see I've gone past my 30 minutes here. So what I'm going to do next week is actually jump into what do we learn about life beyond planet Earth when we look at super galaxy clusters. And here's some examples of these super galaxy clusters. There's 2 trillion galaxies in the observable universe. And if you look at this particular slide, everything you're seeing except for 3 stars. There's only 3 stars in this image. Everything else is galaxies. And so you can just see our universe is filled with galaxies. And these galaxies are organized into super galaxy clusters. And so this is a map that astronomers have made of the farthest reaches of the universe, basically showing not clusters of galaxies, but super clusters of galaxies. And next week I'll share with you, there's tens of thousands of supercluster galaxies in the universe, but as we've examined them all, we live in the only one that has the possibility of advanced life. Our super galaxy cluster is unlike any other. So it's basically making the point, no matter what size scale we look at, we see fine-tuning. We see that we live in a unique system that's uniquely designed to be a house, to be a habitat for advanced life, which is suggesting that we really are alone. I mean, we're living in the only super galaxy cluster that has a capability of housing advanced life. If we're living in the only galaxy cluster that has that capability, if we're living in the only galaxy group that has that capability, the only galaxy, the only bubble within our galaxy that has a capability, the only fluff within our Milky Way galaxy that has a capability. I can go on, I'll stop. But that's kind of a preview of what you'll find in the book, Design to the Core. So let me stop this, and I'll take questions. And that's how this Paradoxes class is organized for all of you newcomers. We typically arrange to speak for 30 to 35 minutes, and then we have another 40 minutes for Q&A. Everything gets recorded, so if you ever miss a section, you can download it for free at paradoxes.org. They're also archived on YouTube, and so the Paradoxes class has a YouTube channel where these things are permanently archived, and so feel free to share this with your friends. People have got questions on these issues. And during the Q&A time, I take questions on any subject. It doesn't have to be related to super galaxy clusters or the supermassive black hole. But again, I posted a lot of the details on my Facebook and Twitter page. Feel free to go there, and feel free to check out that article in the peer-reviewed journal. It was reviewed by theoretical astrophysicists. However, I made sure that the article is accessible for people who are not astronomers. If you want to understand it in great depth, you can go to my endnotes, which are quite extensive. But if you just want to know what it means from a lay perspective, just read the article. It's a quick read. Okay, questions? And we'll take questions too from the virtual audience. Those of you that are here in person, we're also joined by a whole lot of people around the world virtually, and so we let them ask questions as well.
Are those three bright images around the new super center of our galaxy infalling stars or lens effect or something combinatorial?
Yeah, what you're seeing on this image of the event horizon for the supermassive black hole in the center of our galaxy, the brighter spots are high intensity radiation. The dim brown orange spots are much less intense. So the color is designed to show you the intensity of the radiation. And so you can see there's three bright spots that are in this image. Those are regions around the black hole where you got more matter being sucked into the black hole than you got the other regions. But it's not a star. If it was a star, we'd be seeing something really bright. So the biggest stuff that's being sucked into the black hole in our Milky Way's galaxy supermassive black hole is no bigger than a comet or an asteroid. So, and that's good. If it was bigger than that, that would make life here on planet Earth difficult. It would certainly make our civilization challenging. We might be able to survive, but we wouldn't live as long, and we wouldn't be able to sustain the civilization we have. And incidentally, when we go to M87, 53 million light years away, but fortunately, the jet that's coming out from just outside the event horizon, it's pointed away from us. If it was pointed directly at us, even though it's 53 million light years away, we'd be in trouble. But fortunately, it's not pointed towards us.
So one stellar mass star could do us in?
Oh yeah, oh yeah. Now, in this case with M87, it is sucking stars into it, which is why you get such bright light. This was way easier to image because of how much matter it's being sucked in to the supermassive black hole, even though it's 53 million light years away when our Milky Way galaxy supermassive black hole is only 26,000 light years away. That's how much brighter the black hole in M87 is than the black hole in the center of our galaxy. Now, right now they've got the sensitivity to only be able to detect and map the event horizons of two black holes, namely the one in M87 and the one in the center of a galaxy. Those are the ones where they got the largest diameter event horizons. And as you can see, they now have the resolving power of about 25 microarc seconds. It's phenomenal. But they actually have plans to upgrade the telescopes with the goal of being able to image the supermassive black holes event horizon in the Andromeda galaxy. Now, it's 140 million times the mass of our star, the Sun, so it's a lot bigger than the one in our galaxy, but it's 2.5 million light years away. So yeah, they would need an upgraded instrument to have any hope of detecting it. And there's actually a plan by astronomers. What if we put a radio telescope far away in outer space? That would give us a much longer baseline, and then we would have higher sensitivity. And that wouldn't be a lot of money either. It's a relatively cheap project.
With everything that you presented right now, it ties in with Psalms 19, where David writes that the heavens and the expansions declare the glory of God and the handiwork, and the laws of the Lord are perfect. How does all that correspond with, the laws? How does that correspond with further of what you're presenting right now?
Well, I'm older than you are by quite a few years, as most of you can probably tell. And I remember as a young boy that we astronomers were able to explore only 0.01% of the extent of the universe we can explore today. So we know a whole lot more about the universe than we did when I was a young boy. And even if you go back a few years, the database in astronomy doubles about every 5 years. So we know twice as much today as we knew just 5 years ago. And the more we learn, the more evidence we see for the handiwork of God. It's a principle you see in Job and Psalms. The more we learn about nature, the more we learn about what God created, the more evidence we'll find for the supernatural handiwork of God for the benefit of us human beings. And so these event horizon images, which have never been imaged before in the history of humanity, are an example of getting more evidence for God. One of the things we know, this is in the article that I have published, is we wouldn't be here without black holes. Everybody thinks, hey, if there's a loving God, why would he create a universe with black holes? Well, black holes form most often by neutron stars merging together. Neutron stars are very dense bodies, just a little bit less dense than what's necessary to get a black hole, and when they merge together, you always get a black hole. But when two neutron stars merge together, you get this dense flow of high-moving neutrons, and that dense flow of high-moving neutrons is responsible for about a quarter of the elements you see in the periodic table. About a half of the elements that are heavier than iron are predominantly manufactured by the merger of neutron stars to make black holes. And so for us to be here, our planet would have had to have formed adjacent to a neutron star merging event, because our planet is super endowed with the elements that only come from the merging of neutron stars. And that super endowment is one reason why advanced life is possible here on planet Earth. Even in your body, there are these R process elements that come from the merging of neutron stars to black holes. So yeah, come November, when you celebrate Thanksgiving, maybe you want to thank God for black holes. That's just one. There's other things about black holes that are remarkable, making our existence possible. Yes, Martin.
Is this coming through okay?
Yeah.
A question online, Scott. Dr. Ross, what are your thoughts on the Watchers and divine council theory?
Yeah, that's probably coming from Michael Heiser. He's a theologian. He's got a very popular website and also a very popular podcast. And he has spoken and written a lot about the Watchers and the divine council. And his expertise as a theologian is in angels and demons. And I've actually shared the platform with him a couple of times where we talked about angels and UFOs. So I do know who he is. But he has this idea that we need to interpret Genesis 1 as God partnering with a council of angels. So the divine council in his theology is this council of higher order angels that partner with God in bringing about the events we see in Genesis 1. Personally, I don't buy that interpretation. I mean, and this is also in Jewish theology, because when you read Genesis 1, you see God referring to himself in both the singular and the plural. Like when it speaks about God creating human beings, let us create them in our image. So God created them in his image. So you notice that the text is interchanging singular pronouns with plural pronouns. And the way Christians have always interpreted that, we see the word Elohim in Genesis 1:1. Elohim is a name for God that's translated the uniplural one, the one who's both singular and plural at the same time. And so I find it fascinating, right in the very first sentence of Genesis, we have the introduction of the doctrine of the Trinity, that God is one essence manifested as three persons. And with God as one essence manifested as three persons, it makes perfect sense that God could refer to creating human beings with both singular and plural pronouns. But Jews and people like Michael Heiser say, I think that we and us is referring to God partnering with a divine council. So it is an interpretation that's out there. I personally don't buy it, but it is being promoted. And then the Watchers is basically a reference to what's happening at the time of Noah's flood. And we see in Genesis chapter 6 that it uses two words that you find nowhere else in the Old Testament. And the words that are used to describe the evil of the fellow inhabitants of Noah's family. Basically making the point, the evil that was being expressed in the days before Noah's flood has never been matched at any time in human history since. And basically, the two words basically mean this, that all humans, with the exception of Noah's family, were intent on doing physical harm to their fellow human beings all the time. They were incapable of thinking of doing anything good for other human beings. Their intent is to kill and wound and harm every human that they came into contact with. That's how wicked that generation was. The other word is used to describe what they were thinking, and basically saying every thought that they came up with in their head was a thought, how can I do more evil? So, incapable of thinking anything good, incapable of discerning anything as true, and basically explains this is a tumor, a cancerous tumor upon the human species, where evil has been tolerated to such a degree, it's infected the human species, and therefore God had to perform surgery and remove that moral malignancy. But people like Michael Heiser are saying, well, I think this is being explained by these very evil angels coming and communing with humans, and basically that explains why the human species outside of Noah's family became so extraordinarily wicked. And you actually see a hint of that in Genesis 6, 2 and 4, where it talks about the sons of God coming to earth and having intercourse with the daughters of men and giving rise to the Nephilim. And if you read what the rest of the Bible talks about in the Nephilim, they're incredibly evil individuals. So that kind of gives you the context. But again, in my opinion, I'm not a fan of the Watchers. My point is what you see in Romans chapter 1, whenever evil is tolerated and is allowed to run out of control, it's like a malignant tumor in your body. It just gets worse and worse. And what we see in Genesis chapter 6 is how bad things got. Okay, I saw a hand over here.
This is from 2 Thessalonians.
Yeah, put the microphone by your
Oh, yeah,
mouth because
right.
we're trying
Sorry,
to
guys.
record this.
This is from 2 Thessalonians 2, starting at verse 6, going to verse 9. This is New King James. And now you know what is restraining, that he may be revealed in his own time. For the mystery of lawlessness is already at work. Only he who now restrains will do so until he is taken out of the way. And then the lawless one will be revealed, whom the Lord will consume with the breath of his mouth and the destroying with the brightness of his coming. The coming of the lawless one is according to the working of Satan with all power, signs, and lying wonders. So you spoke about how the laws of physics are restraining evil and suffering within the world, or at least the evil. Could this verse be speaking about like the laws of physics being changed by the working power of the enemy?
Okay, we have the promise in Romans 8:23 that the laws of physics will remain in effect until the full number of humans that God intends to redeem have in fact been redeemed. And what you see in the book of Revelation is that after the events that are consistent with 2 Thessalonians chapter 2, we still have humans repenting and coming to faith in Christ. So on that basis alone, I would say 2 Thessalonians 2 is not referring to a change in the laws of physics. Rather, I think it's referring to the Antichrist figure that we see mentioned in the book of Revelation and the book of Daniel, and how Satan will send this figure, probably a human, to planet Earth and establish himself as dictator over all the nations of the world. And what 2 Thessalonians 2 is saying is that the unbelievers of the world will not realize that this ruler is here for evil intent and is a servant of Satan, but the believers will. The believers will know who he is, and they'll know what he's up to, and they'll take appropriate actions to try to bring as many people to faith in Christ in that context. But the unbelievers will not know at that point that he has a theological or religious agenda. What you see later on in both Daniel and Revelation, a time comes when it's not just the believers that know what this dictator is up to, the unbelievers will discover it. Because halfway through of this world dictator, he will set himself up as God to be worshipped. And no one will be able to buy and sell unless they commit themselves to worship this dictator as God. Then the unbelievers will know, okay, this is not just a political ruler, it's not just an economic ruler, because it also tells us that when he comes to power, he's going to bring about an economic boom over the planet. So people are going to say, hey, look at all the wealth we have, this is a good thing. But halfway through his reign, he says, hey, if you want this wealth to continue, you have to worship me as God. And that's what's frightening to the unbelievers. And this is what's going to cause a lot of them to come to faith in Jesus Christ. So yeah, no change in the laws of physics. That doesn't happen until the full number of humans has been redeemed. By the way, if you want to go into that in detail, 40 years ago, I taught on the book of Revelation and 2 Thessalonians and Daniel and all the Old Testament prophetic books. The entire course was recorded. It took 7 years for us to teach the course, but it all got recorded and you can download the MP3s.
Nice.
Yes,
Question from
this is from the internet.
the Zoom the YouTube audience. Lipping Zhang,
Yes, I know who he is.
he asks if the moon no longer has a magnetosphere, does this mean that its colonization would be impossible?
Yes, I mean, we can put a colony on the moon, but you will not want to stay very long on the moon because there's no magnetosphere. Now, there is an option. You could build an underground habitat, and if you put it sufficiently underground on the moon, that would give you adequate protection from the solar and cosmic radiation. But a number of experiments have been done on humans where we try to get them to live underground for a significant period of time, and they discovered humans are not psychologically designed for that environment. They can maintain their sanity for a couple of months, 6 months. They found that women can maintain their sanity a lot longer than men, for several obvious reasons. But even women reach a point where they're no longer able to function under those conditions. And so, and there is plans to try to establish a habitat on the moon, but the plan is that people would go there for days only. And so if you go there for a few days, yes, you'll be exposed to some radiation, but it's not going to be enough to kill you. And by the way, if you schedule your time, you could be protected by Earth's magnetosphere, because Earth's magnetosphere is kind of tear-shaped, and so as the moon is orbiting about the Earth, it passes through Earth's magnetosphere. So if you make your trip to the moon when the moon's going through Earth's magnetosphere, you're going to be fine. And that's exactly what they did with the Apollo program. They timed the arrival and departure of the Apollo astronauts so they'd have maximum protection. So that works great on the moon. It doesn't work for Mars because the magnetosphere peters out quite quickly, and hey, it takes a lot longer to go to Mars than to the moon.
If you've projected that there would be some kind of fossils of ancient life having been ejected onto the moon, why would this radiation not have disintegrated those fossils?
Well, if those fossils get buried, then they would be protected from that radiation. And if they're microbes, they're going to be much hardier. Now, we're not talking about viable. There's no way that microbes that got transported from the Earth to the moon are going to be able to be alive for very long. There's some speculation that some might be able to survive a year, because there is microbes that are actually radiation tolerant. So there are bacteria near Chernobyl, for example. There's a couple of species that can tolerate a lot of radiation. But we're looking at the remains of Earth life, as I said, fossils. And so the fossils will be relatively tolerant to the radiation, but not live microbes. Live microbes are going to get zapped pretty quickly.
How long would they last, though? So how far back in our history could we expect to find these fossils? In other words, how old would they be?
Well, the oldest fossils we've found on Earth, and there are fossil parts of microbes, date 3.47 billion years ago. But we know from isotopes life has been here on Earth since 3.825 billion years ago. So that's the goal. Go to the moon and actually find the very first fossils of Earth's life. Yeah, and the fossils should be in relatively pristine form on the moon because of the fact that there's no geology to disturb them. Yes, there's radiation, and the radiation will certainly kill the microbes, but shouldn't disturb the fossil structure of those microbes.
Thank you.
Two questions real quick connected. If the flood destroyed everything, wiped out everybody, the creatures in the sea were not killed. And the other question, if God wiped out everybody, how come we have giants now like Goliath and those? And we speculate that the Nephilim survived or somehow.
Yeah, what was your first question again?
If everybody was wiped out, the creatures in the sea doesn't say that they all died. And of course they own the water.
Right. Yeah, the flood of Noah, as you can see when you look up the Hebrew words for the animals that were destroyed by the flood, they're the soulish animals that were in association with the humans. So we humans domesticate all kinds of animals. We tame all kinds of animals. What the text is saying, all humans except for Noah's family and all the animals associated, the soulish animals associated with humans, were destroyed by the flood. But as you point out, that doesn't mean all life was destroyed by the flood. For example, I don't think there were any polar bears or emperor penguins on board Noah's Ark. Those animals would have had no contact with humans and therefore no need for God to deal with them. And this is a principle you see in the book of Leviticus, where it makes the point that when you got an evil human being that has a domesticated animal, that domesticated animal will pick up on the behavior of the human. Why? Because these soulish animals, God designed them to serve and please their human owners. And, you know, in the old days, I was a full-time minister of evangelism in a church not too far from here, and I'd take people door to door to do evangelism, to talk to people, and I would train them. Look out for the pets. If the pets are vicious and are trying to kill you, then chances are you're going to be dealing with a vicious owner. Because what's happening is the animal's trying to please its owner, and of bringing pleasure to the owner is this animal attacking and destroying other animals and humans. That's what you're going to run into. Which explains why God said we have to destroy not just those wicked people, but all the animals under their possession. But animals that are not under their possession wouldn't be degraded by the evil of those people. And so I don't think God bothered with the kangaroos. He didn't bother with the polar bears or the penguins or any other animal that had no contact with those human beings. And you see this explicitly in 2 Peter 2:5, where it says the flood of Noah destroyed the world of ungodly people. It doesn't say the whole planet. It says the world of ungodly people. So everywhere that ungodly people lived, and all the animals that were associated with those godly people were destroyed by the flood, with the exception of Noah, his family, and the animals that were there with Noah. And your second question again was?
If God wiped out everybody after the flood,
Yes.
so why do we have giants today?
Yes. Question. Genesis 6:2 says that there were these giants in the land in the days before the flood. Why? Because these sons of God came and had intercourse with the daughters of men, and they gave rise to this Nephilim. And one purpose of the flood was to wipe out all these wicked Nephilim. But what does Genesis 6:4 say? They came back. The sons of God came back after the flood and also in intercourse with women and gave rise to a new generation of Nephilim. And this is why you see in the books of Moses and in Kings and Samuel that we have God working with the Israelites to wipe out the new generation of Nephilim. And so what you see in Deuteronomy, for example, and Numbers, is God saying to Moses and the Israelites, you need to take care of these Nephilim around you. And then when they entered into the promised land, what you see is God raising up David's 30 mighty men. They were not only very successful in battle against the Philistines, they wiped out the last of the Nephilim. So there's never been a Nephilim on the face of the earth since David's mighty men 3,000 years ago. Now, I say that because some Bible prophecy teachers on the radio are trying to raise fear by saying the Nephilim are with us today. And they're not. In fact, it's impossible for a mere human to reach the height of even the shortest of the Nephilim. The shortest Nephilim mentioned in the Bible is Goliath. He was a minimum of 9 feet 9 inches tall. The maximum height a human can attain is about 8'11". Once you get past that, the body quickly wears out and dies. There is one individual who hit 8'11", and he died before he reached his 40th birthday from physical exhaustion. That's because for us humans, the weight of your skeleton goes up with the square of your height. So it explains why the tallest players in the NBA are the slowest players in the NBA. They got way more bone mass that they have to move down the basketball court than people that are shorter than they are. But hey, put them in front of a basket, they can just drop it in the basket, right?
Yeah, so I was thinking about when you're talking about the habitable zones, right? We know that the way that our cells and our bodies are set up works like here on planet Earth, right? Isn't it possible that we could have life forms that are, dramatically differently or, have very different assumptions than what is here on Earth, and maybe have life in some of these places that we think of as not habitable?
Okay, let me go a couple of ways with your question. I mean, one way, and this I see in the literature all the time, who says it's got to be life as we know it here on Earth? And, in terms of the fine-tuning arguments we make here for God at reasons to believe, the assumption we make is if it's a physical organism, it's carbon-based. And my colleague Fazal Rana has written a number of papers on this. I've written some too, making the point when you look at the periodic table, there are what looks like possible candidates. The three best are boron, silicon, and arsenic. But in all three cases, you do not get the bonding stability or the bonding complexity that you get with carbon. And so you're not going to be able to make life based on arsenic, boron, or silicon. It's got to be carbon-based. Now, I did debate Victor Stenger about this issue, and he said, well, couldn't there be alternate life forms subject to different laws of physics? I said, well, if you're talking angels, definitely. They operate under different laws of physics. But guess what? Their realm is fine-tuned, just like our realm is fine-tuned. But yeah, if you're talking about life, that's kind of what I'm talking about in this series. Is there a possibility of life elsewhere in the universe that, like us, is constrained by the laws of physics, which means it must be carbon-based? Now, you had a second component to your question. I'm trying to remember what it was.
Yeah, I think the carbon base I think makes sense, but from the how the cells are structured, right? Are there maybe different configurations within it?
Yeah, that's an interesting point because, for example, people have said, well, how about life on another planet where the gravitational force on the organisms is different? I mean, here we have 1g on the surface of the Earth. Is it really possible to have a thriving ecosystem on the surface of the moon where the gravity is only 1/6? And then you can ask the question, well, what about a different radiation environment? Well, we've written a number of articles basically saying the constraints are quite tight. Certainly the radiation constraints are tight for all carbon-based life. You may have a little bit of flexibility with the gravity if you're talking about organisms that don't live a long time. Because, trying to survive, say, in the gravity of Mars, you're going to be fine if you're there for a few years. If you're there for decades, it's not going to go well for you. If you ever go to one of these NASA space camps, they actually let you feel what it's like to be under a different force of gravitational pull. I've taken one of my sons to those camps. And what's really interesting is how challenging it is to walk with a different gravitational force. So like if you go up to, say, 1.5 Gs, your body weighs a lot more. And so you expend a whole lot more energy trying to walk. You are stable, which is interesting. Lots of gravity makes it possible to have stable walking. But you wind up expending a huge amount of energy and you're basically wearing your body out. The problem with less gravity is you lose the stability. And so it was really quite remarkable. Like with Mars, it has 45% of the gravity that you get on the surface of the Earth. And I don't know if you ever saw that movie, The Martian, where it shows Matt Damon going on a long hike on the Martian surface. Not possible. The force of gravity simply wouldn't now allow anyone to walk like that on the surface of Mars. And then try it with the moon. One of the things they tried to do with the NASA Apollo astronauts is put a huge amount of weight on their back to give them extra gravity. So those Apollo astronauts had 250-pound backpacks on. And they needed that to get the air conditioning and heating they needed. But even then, it was very difficult for them to walk on the moon. They basically did this jumping bunny hop in order to stop themselves from falling over, which is why on the later Apollo trips they said, forget it, we're going to give you a vehicle. So all they had to do is make a couple of steps towards the vehicle, get in, and they didn't have to worry about falling over and doing themselves serious harm. So we're blessed to have 1G gravity. It's the optimal gravity to have for maximum mobility and maximum lifespans.
Hugh, I think our time is up. Could
Okay.
you please dismiss us in a prayer?
I'll be happy to do that. Father in heaven, we thank you that you've given us a Sabbath where we can take a day out of the week and focus on the most important issues of life. Father, I pray that each of us would have opportunities to talk about this, not just on Sunday, but on other days of the week with people that we meet, people who may not be taking that time to focus on the most important issues of life. So give us those opportunities. And Father, we thank you that you're there to give us wisdom when we need it, grace and humility and love and compassion when we need it. Open up our hearts, Lord, to receive what you're prepared to give. In Jesus' name, amen.